Hello, this is Dr. Mears, and today we are going to be doing examples of trigonometric ratios in the unit circle. Now, I also have a video about the unit circle, and it introduces you to the unit circle, so if you would like to watch that, you are more than welcome to. So let's do some examples. Number one, find the sine of, part A, cosine of 140. Now, when you're reading these, this word is key because our answer is either going to be a positive or just a negative. That's it. They just want you to find what would this answer be? Would it be a positive answer or would it be a negative answer? And so you could simply do this on the calculator. Boom, clear that out. Let's make sure that we're in degrees. We have degrees. Quit. So cosine of 140, that gives us a negative 0.766. Okay, that is easy, but this is about the unit circle. So let's take out our unit circle because it's going to show you why cosine of 140 is negative. Here's our unit circle. And so I wrote a couple notes on here. Here is quadrant 1. Remember, x corresponds to cosine, y corresponds to sine. This is positive. Thank you. Okay, so in quadrant 1, x is positive, y is positive. Therefore, cosine is positive, sine is positive. Okay, let's look for quadrant 2. In quadrant 2, x is negative, cosine, y is positive, sine. In quadrant 3, x cosine is negative, y sine is negative. And in quadrant 4, x cosine is positive, and y in quadrant 4 is negative. Okay, so what do we have to do to find the cosine of 140? Well, the first thing is to locate 140, locate that angle. And so if we look, 140 probably will be about around here. Somewhere around here, this is 140 degrees. I'm not exact, and that's not a perfect line. I'm actually going to erase that line because that's an awful line. But that angle would probably be somewhere around there. Okay, so knowing that it's in the second quadrant, and we're looking for cosine, in the second quadrant, cosine is negative. So that's how we know, and that's, whoops, sorry, bumped my camera. That's how we know that this is going to be negative. If you want to write the word out, you can, absolutely fine. I'll take either one. Okay, let's try sine of 310. So is this answer going to come out to be positive or negative? Let's look at our unit circle. First, let's locate 310. Well, 310 would be someplace around here, between 300 and 315. Now, we want the sine. Sine corresponds to y, and in the fourth quadrant, sine is negative. Negative. Done. Okay. Tangent. Now, here's the story about tangent. When we were looking at the special right triangles, tangent is the tangent of theta would be opposite over adjacent. So for here, I want you to think about it as y divided by x. That's what tangent is. Cosine's x, sine is y, tangent is going to be y over x, or sine divided by cosine. It all dates back to the special right triangles when we're finding the different sides, opposite, adjacent, hypotenuse. It all dates back to there. So moving forward into the unit circle, it's always going to be y divided by x, or sine divided by cosine. So now what we're actually looking for is we're going to have to look for the sine of 135 and divide that by the cosine of 135. And I just want their actual signs, whether it's positive or negative. So let's go look for the sine of 135 degrees. So first, locate 135. Here we see 135. We have second quadrant. In the second quadrant, sine is positive. So sine is positive. And in the second quadrant, cosine is negative. So if we divide these, our answer will come out to be negative. If we did it in the calculator, you'd get a negative answer. Okay. Number 2, find an obtuse angle that has the same sign as the given acute angle. Word change, sine. So what they want you to look for is there is going to be another angle that I could take the sine of that will give us the same answer. Here's another word to look out for, obtuse angle. What does this mean? This means in order to find that other angle where we would get the same answer, we would either have to take 180 degrees and subtract the angle that they gave us, or if they gave us in pi radians, we would do pi minus the angle measurement. So here they gave us 70 degrees, it's in degrees. So in order to find that other obtuse angle, all I do is I take 180 and I subtract 70. So 180 minus 70 is going to be 110 degrees. What this means is if I put this in the calculator, these two will come out to be the same answer. Let's try it. Let's check it. Okay, on. Clear that out. So let's put sine of 70. That gives us 0.9396. All right, three significant figures, it would be 0.940. All right. Now, if I put in the sine of 110, I get the same answer. And I forgot my parentheses there, but it's okay because we're just doing this one little key. We're not multiplying by anything. So try to remember parentheses. Sorry, I did there. But we do get the same answer. Three significant figures, 0.940. So that checks out. All right. Now let's do it in pi radians. So here we have the sine of pi over 4. So there is another angle measurement, and we can get that angle measurement by now doing pi minus pi over 4. Okay, here we're going to have to do a little bit of work in order to combine these together. I don't want you using your calculator. So what I'm going to do is take just a quick short detour. We're going to do pi minus pi over 4. Now when we do this, we have to have a common denominator. So I have to put pi over 1. Our common denominator is going to be 4, which means I can multiply this by 4, and I can multiply this, meaning the numerator, and I can multiply denominator by 4. Okay, 4 times pi is 4 pi. 4 times 1 is 4. Bring my minus over, bring my pi over 4. Okay, let's subtract them. This pi really has a 1 in front. If there's no number, it's a 1. So now I have 4 pi minus 1 pi, which is going to give us 3 pi. Over or divided by, and then move your denominator over. That should just move it over. So 3 pi over 4 is going to be our answer. Okay. So sine of 3 pi over 4. That should give us the same answer as pi over 4. Now, and we can put parentheses around this, that's fine. But we're not going to do this in the calculator. We're actually going to use the unit circle to prove that these two are going to be the same answer. So what we're going to look for is sine of pi over 4. Okay, so we're going to come here. All right, pi over 4 is here. Okay, now remember, x corresponds to cosine, y corresponds to sine. So the sine of pi over 4 is going to be equal to the square root of 2 over 2. Square root of 2 over 2. Okay, let's locate 3 pi over 4. Okay, where's 3 pi over 4? You guessed it, right here. All right, x is cosine, y is sine. So 3 pi over 4, the sine of 3 pi over 4 is the square root of 2 over 2. Same exact answer, I'm able to check it. So I like these because you can check your own work. All right. Next, number 3, find another angle less than 360 or 2 pi that has the same cosine as the given angle. So now we're looking at cosine, and we're actually expanding our circle. It's now 360 or 2 pi. So that means we're either going to be doing 360 minus the angle, or if we're given pi radians, 2 pi minus the angle. All right, so what does that look like? Here we have cosine of 50 degrees. There's another answer that's going to be the same. Actually, there's the same answer. And we get that by just subtracting 360 and 50. Okay, so this is going to be cosine of 310 degrees. That should give us the same answer as cosine of 50 degrees. Do you want to check it? Of course we want to check it. What does this look like? All right, so clear that out. Cosine of 50, closing my parentheses is good practice, is 0.643 to 3 significant figures. Okay, we should get the same answer with cosine of 310, 0.643. Check. Excellent. Okay. Now let's do cosine of 2 pi over 3. We're going to be able to get the same answer, but we have to now subtract 2 pi minus 2 pi over 3. Yes, there is going to be some not decimal work, some fraction work here. So let's go see what that looks like. I will do that with you. All right, so we have 2 pi minus 2 pi over 3. Just checking, it is 2 pi over 3. Perfect. Okay. We have to put 2 pi over 1. The common denominator, yes, it's going to be 3. So I'm going to multiply numerator and denominator by 3. 3 times 2 is 6 pi. 3 times 1 is 3. Bring over my subtraction. Bring over my 2 pi. So we have 6 pi, 2 pi over 3 I meant. We have 6 pi minus 2 pi. 4 pi, bring over your common denominator. You don't have to do anything, just bring it over. All right, so we have 4 pi over 3. That's the one that's going to give us our same answer, 4 pi over 3. All right, let's go check this out. So let's see. We're going to need to go to 2 pi over 3 on our unit circle and look for that cosine. All right, let's find 2 pi over 3. Right here, 2 pi over 3. Okay, remember, cosine is x. So here is our x, which is negative 1/2. Oops. So this is negative 1/2. Okay. Now, let's look for cosine of 4 pi over 3 and see if we get the same answer. 4 pi over 3, down here. Look at how nice and symmetric this is. Look, 4 pi over 3, 2 pi over 3. And guess what? Yes, same answer, negative 1/2. Negative 1/2. Okay. Last one, number 4, so that checks out, yay. Solve these equations, it should be equations, sorry everybody, for 0 is less than theta, which is less than 2 pi. So what they want us to do here is they want us to find the angle measurement. So they're going to want us to find something that looks like 2 pi over 3, or 50 degrees. So we are going to have to use our unit circle, or in other cases, we're going to use our calculator. I'll do both for this one. This one is going to be a decimal. So, all right, let's do part A first. So here's the thing. Let's look at our unit circle. We need to solve for theta, and this just means we have to look at the entire circle. We get to look at all 4 quadrants. So we get to look at quadrant 1, 2, 3, 4. So from 0 all the way around to 2 pi. Remember, 2 pi is 360. So this is 2 pi, which is 360 as well, if you go all the way around, okay? What we have to find is we have to find positive 3 over 2. So where we have a sign, the answer has to be positive 3 pi over 2. So let's look for that answer on our unit circle. So we're looking for a y value of positive 3 pi over 2. Okay, I see a positive 3 pi over 3, sorry. Did I say 3 pi? The square root of 3 over 2. So here's a positive square root of 3 over 2, which is at pi over 3, which is 60 degrees. Okay, is there another positive square root of 3 over 2? Yes, right here. Perfect, which is 2 pi over 3 and 120. Are there any other positive square root of 3 over 2's? Nope, that one's negative and that one's negative. All right, so my 2 answers are going to be 60 degrees and 120 degrees. I'm going to write both radians in degrees for you. Okay, so we have pi over 3, which is 60 degrees, and we have 2 pi over 3, which is 120 degrees. Now, which one do you know to do? If they give you pi radians here, then they're going to probably want the answer as pi radians. However, for this one, we're going to see that it's going to come out to be a decimal. So if you didn't have your unit circle and you were able to use your calculator for a problem like this, what would happen? Well, remember, we want to solve for theta. And in order to solve for theta, you have to take the inverse of sine. So in your calculator, you would do the inverse. Because remember, in order to get inside the inside angles, you have to take the inverse to get inside to see what the angles are. So on your calculator, you're going to be doing sine, oh, no, sorry, second sine, there we go, inverse sine of the square root of 3, and please over arrow button because I don't want this division symbol underneath the square root over 2. We get 60 degrees, yay! Okay, 60 degrees. Now, here's the thing. It won't give us that other one, right? So we're stuck at 60 here, but we know there's another positive answer, okay? So how do we know where it is? Well, we need this answer to be positive. And so that other positive answer, where y is positive, is in the second quadrant. So in order to get to 120, we do 180 minus 60, and that gives us to 120. Remember, we have to do 180 minus theta to get to quadrant 2. Oops, sorry. We have to do 180 minus theta to get to quadrant 2. We learned about this in my last video, trigonometric ratios in the unit circle. We also learned how to get to quadrant 3 and quadrant 4. So if you need a refresher on that, I would highly suggest going back. Okay, tangent. Okay, so here's the thing about tangent. We're revisiting tangent. So tangent is really sine theta over cosine theta to give us a square root of 2 over 2. First, let's take a look at this on the calculator. And why do I go there versus the unit circle? Well, it's tangent, and I want to see if we're going to come out with a decimal. So just as a person of math, this is what I do. So how do we get inside? Well, we can do the inverse tangent, which we do have on our calculator, so we don't necessarily have to change it to sine over cosine yet, of the square root of 2 over 2. Let's see what that looks like, okay? Because if it's not a decimal, then sweet. But if it is, then we don't have to waste our time going to pi radians here. All right, so we do inverse tangent of the square root of 2, move over, divided by 2. Okay, we are going to be getting 35.264. So it's not 30 degrees, it's not 60, it's not 45. So this is a decimal answer. So the only practical thing we can do is just use our degrees here. So let's just use our degrees. So we have 35.2 degrees. Now this is in quadrant 1, and we have sine divided by cosine in quadrant 1 is positive because it's going to be a positive divided by a positive. So that's great. Where is my next answer where we come out with a positive answer? So where is sine divided by cosine positive? Where is that? Well, let's look. Quadrant 3, if we divide a negative by a negative, we are going to get a positive answer. So we need our other answer in quadrant 3. This wouldn't work because if we divide that, that would be negative. And this wouldn't work because if we divide that. So the signs have to be the same. And they're the same in quadrant 1 and in quadrant 3. But how do we get our answer in quadrant 3? Well, remember, quadrant 3's answer comes from taking 180 and adding theta, in our case, 32.5. So let's do that. So let's do 180 plus 35 point. And it's actually, thank you everybody, I didn't do 3 significant figures. I'm sorry for the erasing. It's 35, and I'm rushing it. 35.3. Okay, 35.3. There we go. Sorry, I wasn't correct in the significant figures, and I confused my numbers down here. So 180 plus 35.3, that gives us 215.3 degrees. So now I'm positive in the first quadrant, I'm positive in the third quadrant, and I have solved the tangent theta equals the square root of 2 over 2. I hope this helped. This has been we went into the land of solving equations, and we are going to be coming back here, but that's in my next video. So I hope this helped. Examples of trigonometric ratios in the unit circle.